We're gonna solve equations today, and the equations we're gonna work on in this video are exponential equations. And so where we're gonna start is we're gonna start with a statement. And this statement comes from the one-to-oneness of our exponential functions. We know that y equals b to the x is a one-to-one function. So another way of saying that is saying b to the x equals b to the y if and only if x equals y. So the way we're going to work with this equation, or with this statement today, because we know if and only if means we can read it in either direction. But in this video, we're going to work with it from left to right. So to start with some equations that are very short and sweet, maybe if we have 2 to the x equals 2 to the 5, say if the bases are the same, then the exponents have to be the same as well. So we can conclude that x equals 5. Or if we have 3 to the x equals 3 to the negative 4, say, well, those bases are the same. And if the bases are the same, then the exponents have to be the same as well. Now, of course, our equations aren't going to be given to us quite this straightforward. We have to do some work maybe to get to this step. But the idea is if the bases are the same, then the exponents have to be the same. And so the conclusion we can draw from here is that x equals 1/2. Now maybe I have not just a plain old x up here. Maybe I have 2 to the x plus 3 power equals 2 to the 9th. Then if the bases are the same, we conclude the exponents are also the same. So I say x plus 3 has to be equal to 9. And what I'm left with is an equation that I can solve in one step, and I can find out what x is. So if I can make the bases the same, then I know the exponents have to be the same. And I'll just keep saying it over and over and over again. So maybe my equation says 2 to the x equals 16. And so the first thing, if I'm trying to solve for the exponent, the first thing that I want to do is I want to determine whether or not I can write both sides as powers of the same base. Meaning if I can write 16 as a power of 2, then my job is easy. Because I say, if 2 to the x equals 2 to the 4, then that can only happen if x equals 4. Or maybe I have 5 to the x equals 1 over 125. If I can write both sides as powers of 5, then I can set the exponents equal, and I can solve for x. Now I know that the number 125 is 5 cubed. And if 5 cubed is on the bottom, but I need to pull it back up to the top. If I pull it back up to the top, that makes that exponent negative. So now I can say, well, if 5 to the x equals 5 to the negative 3, that can only happen if x equals negative 3. Maybe I have 7 to the x power is equal to the square root of 7. Now our negative exponents are the ones that are on the bottom of the fraction. When we pull them back to the top, they become negative. But our roots and radicals, when we write them as exponents, those are our fractions. So a square root is the 1/2 power. The cube root would be the 1/3 power. Fifth root would be 1/5 power, and so on. If I can write both sides as powers of the same base, then I can set the exponents equal and solve if there's anything to solve. These three, there was nothing to solve. So maybe I have 3 to the x minus 4 power is equal to 27. So when I look at the number 27, I recognize that 27 is 3 to the third power. And now that I have the bases the same on both sides, I can set the exponents equal, and I can solve for x. Adding 4 to both sides, I find out that x equals 7. Now, sometimes we have a problem like this one. 9 to the x equals 27. Where if I look at 9 to the x power, I look at 27. 27 is not a power of 9. It's a multiple of 9, but not a power of 9. However, if we break things down, we notice that both sides are powers of 3. So we can write 9 as 3 squared. That's supposed to be an exponent. And 9 is raised to the x power. So when we have an exponent to an exponent, that was clear back in the first chapter, we know that a power to a power means we're going to multiply those exponents. And so then if we have 3 to the 2x equals 3 to the third, we can conclude that the exponents have to be the same. 2x is equal to 3. So that gives us x is equal to 3/2. So they can be distinguished from the others. Okay, so maybe I have 4 to the x equals 1 over 32. Again, 32 is a multiple of 4, but not a power of 4. However, think about what smaller base, smaller number than 4 that both 4 and 32 are powers of. Write both sides as powers of that number. And then you can set the exponents equal to each other, and then you can solve for x. Go ahead and pause it if you want to try it on your own. Turn it back on when you're ready to see the answer. Both 4 and 32 are powers of 2. 2 squared to the x is 2 to the 2x power. 32 is 2 to the 5th, and when I bring it up to the ground, it becomes a -5 there. So we find out that x is -5/2. We're going to do one more of these, and then we'll make another video over what to do if we can't take this approach. Okay. Let's say 8 to the x minus 1 equals 16. Okay, pause the video at your desk to see what you can do with this, and then turn it back on when you're ready to see the answer. Both 8 and 16 are powers of 2, and so we can write 8 as 2 cubed and 16 as 2 to the 4th. Now here in the next step is where some of you will make a mistake, because when we multiply those exponents, don't forget we have to distribute. 3 times x minus 1 is going to be 3x minus 3. So from here we can say, well, 3x minus 3 equals 4. And I'll put my little x there. 3x equals 7 and x equals 7/3. Okay, give these a shot. These are found in section 4.2, actually, of your textbook. But I do them with the 4.5 stuff because they go along with the rest of that section.